Okay, let's dive right into it. If you spend any time writing code, you already know that repeating yourself, well, it's pretty much the enemy of efficiency, right? Functions are exactly how we fix that. They turn messy, repeated logic into a clean, reusable tool. Welcome to this explainer. Today, we're building a real working Python function step by step. We're going to cover everything from basic return values and type hints to returning multiple values at once. And then, we're mastering two incredibly powerful, super flexible features, star args and double star kwargs. By the end of this, you'll know exactly how Python passes data in, and more importantly, how it passes data out. So let's get started. Here's our roadmap for the explainer. We'll start with basic functions and return values, move to clarity with type hints, and then returning multiple values at once. After that, we're looking at positional arguments with star args, keyword arguments with double star kwargs, and we'll wrap the whole thing up with the complete function toolkit. Section 1. Basic functions and return values. To make this practical, let's use a scenario you might actually code, calculating a profit margin. Take a look at the architecture here. The function takes two inputs, revenue and expenses. Inside the block, it calculates the profit by subtracting expenses from revenue. Then, it figures out the margin by multiplying that profit by 100 and dividing by the revenue. Finally, it sends the result back to you using that absolutely crucial word right there, return. Let's trace the data for a second. If our revenue is 50 and expenses are 10, the profit is 40. The margin is 40 times 100 divided by 50, which equals 80. So the real star of the show here is that return keyword. Because honestly, without return, this function would run perfectly, do all that beautiful math behind the scenes, and then give you absolutely nothing back to use in the rest of your program. It'd be like cooking a massive dinner and then just throwing in the trash. And when we print the result of that calculation, the output we get is 80.0. Notice that it's a float, a decimal number, not an integer. In Python, division always returns a float, even if the numbers divide perfectly evenly, just like ours did. It's a small detail, sure, but a really important pro tip to keep in the back of your mind when you're structuring your data. Section 2. Clarity with type hints. Writing code that works is great, right? But writing code that's easy to read and debug is even better. We really want to upgrade our basic code by making it self-documenting. First up, notice you don't actually need to pass raw numbers into your function. By passing variables, like defining revenue as 80 and expenses as 60, Python just substitutes their values perfectly. But look down at the function definition where it says rev::float and exp::float. Those right there are type hints. Now, this isn't some strict rule that Python enforces when the code runs. Instead, it's more like a sticky note for you or anyone else reading your code, saying, hey, this parameter really should be a decimal number. And that little arrow and the word float at the end, that tells you exactly what kind of data the function is going to hand back. So while type hints don't change how Python actually executes your code, they make everything incredibly self-documenting. Plus, your code editor can use them to catch pesky mistakes before you even hit run. Section 3. Returning multiple values at once. Okay, this is honestly one of my absolute favorite features in Python, mostly because it just brilliantly shows how simple the language can be. In a lot of other languages, returning multiple values means setting up complex arrays or building custom objects. But in Python, you literally just separate them with a comma. Look at the line there, return profit, comma, margin. Down below, when we call the function, Python seamlessly unpacks those two returned values directly into the two variables we've got waiting on the left side of the equal sign. Profit gets 40, margin gets 80.0. I mean, it basically reads like plain English. To truly master this, we kind of need to demystify the behind-the-scenes magic. What is Python actually doing when you use that comma? It all happens in a really simple two-step sequence. Step 1, Python silently bundles your values together into a single data structure called a tuple. Then, step 2, Python takes that tuple and instantly splits it apart, assigning the pieces directly into the variables you provided. Bundle and split. It's that simple. What's really great is that you are in complete control of this entire process. Let's say you choose not to provide multiple variables to unpack into, like we're showing here, just assigning the whole result to a single variable called response. Well, Python just says, no problem, and hands you back that raw tuple. You can actually see the class type is tuple. And from there, you can just access the individual items using index numbers, the exact same way you would with a list. Index 0 gives you the first item, 40. Index 1 gives you the second item, 80.0. All right, let's step it up. Section 4. Positional arguments with star args. So far, we've built functions with a set number of inputs. But what if you're building a tool and you have absolutely no idea how many numbers someone will need to pass into it? Let's ground this concept in plain English before we look at the syntax. When you see an asterisk followed by the word args, which we pronounce star args, it simply tells Python, accept as many positional arguments as the user wants to throw at you. It's basically an infinite net for data. Let's see how this actually plays out in the code. We have a function called calculate_expanse, and we define it with star args. Down below, we call it and pass in 3 numbers, 2, 3, and 7. Python just collects everything you passed into a tuple, exactly like we saw in the last section. Then the built-in sum function just adds up everything inside that tuple. Let's trace the math real slow. 2 plus 3 is 5, plus 7 equals 12. And once again, notice our spotlighted return statement sending that 12 right back. Now look down at that bottom example. We pass in 2, 3, 7, 9, 897, and 88. It literally does not matter if you pass in 6 numbers or 60 numbers. The function handles it the exact same way. It dynamically adapts to whatever the user throws at it.
Section 5. Keyword arguments with double star kwargs.
So star args gives you infinite positional inputs, but what if those inputs need labels? Well, that brings us to the next level of ultimate flexibility. The absolute crucial point of differentiation here is that double star kwargs is very similar in spirit to star args, but it's specifically designed to accept named arguments instead of just plain sequential values. You're going to want to use this when the label of the data is just as important as the data itself. In our total exp function, taking double star kwargs, because these inputs have names, Python doesn't bundle them into a tuple this time. Nope, it bundles them into a dictionary. Inside the function, we set up a simple for loop. This loop calls kwargs.items to deliberately walk through each key value pair in that dictionary one by one. It grabs the value from each pair and just adds it to our running total. And right there at the very end is our return total line, making sure we get our final sum back. Let's slow down for just a second and walk through exactly how this dictionary conversion happens step by step. When we call the function, we pass in rent equals 1,000, phone_bill equals 30, and Waymo equals 20. Python maps all these out perfectly. The key rent maps to the value 1,000, phone_bill maps to 30, and Waymo maps to 20. Our for loop just steps right through these. First, it sees rent and adds 1,000 to our total of 0. Next, it sees phone_bill and adds 30, bringing us to 1,030. And finally, it sees Waymo and adds 20. So 1,000 plus 30 plus 20 perfectly leads us to our final output of 1,050. It's dynamic, it's clearly labeled, and it is just incredibly powerful.
Section 6. The complete function toolkit.
We have covered a tremendous amount of ground here, moving from basic structures all the way to highly dynamic input handling. I highly encourage you to screenshot this toolkit right now. This is basically your ultimate cheat sheet for everything we've just learned. We have def to actually create the function. We have our crucial return keyword to send a value back out. We've got type hints to cleanly suggest expected data types to other programmers and to your editor. We have tuples, showing how Python handles multiple returned values in parentheses. And finally, our ultimate flexibility duo, star args to accept as many positional arguments as you want, and double star kw args to accept as many named arguments as you want. Take a second to just absorb the full power of defining, returning, and handling flexible inputs that this table represents. So you now have the complete foundational toolkit for passing data in and out of Python functions. But here's the really exciting part. This is just the beginning. The logical next step in your programming journey is taking these standalone functions and moving them into object-oriented programming. That's where these exact same flexible functions become methods living inside classes. So armed with this brand new knowledge of return values, unpacking, and infinite keyword arguments, how will you structure your next flexible piece of code? Thanks so much for joining me on this explainer. Keep building, and I'll see you next time.